We haven't graphed that in a long time, and it's just giving me a chance to remind you of how things move. So what does this start as? A parabola. And then it moves where? To the right, how far? 3, and then what's the plus 1 do? Up 1. All right, awesome. Now, you could graph a parent parabola and then grab every point on it and move it to the right 3, and then grab all those points again and move them up 1, and it would work. But I've told you that your best friend in graphing is the XY chart. Excellent. And you know then that you could just stick in some points. Now you just want to pick random numbers? Now you want to be strategic. What's a really handy thing to put in? 3, because it makes the inside part 0. We're going to have something just like that today in log graphing, where you're going to make the inside part equal 0. On a log, it's called the argument. Anyway, but this part becomes 0, and then plus 1 makes 1. So when I stick in 3, I get 1. Give me one more point. K, H. 4, I like it, because then this is easy. And that's what you're going for, is something easy to work with. 4 minus 3 is 1. 1 squared is 1 plus 1 is 2. All right, give me one more point. PW, negative 1. Ooh, tried something different. So if I put in a negative 1 right here, I get negative 1 minus 3, which makes negative 4. I square it, makes 16, plus 1 is 17. I liked it until I saw the ending, and it's probably off the graph. Okay, so let's just do one more, Mr. H. All right, let's put in a 5. 5 goes in here, and 5 minus 3 is 2. 2 squared is 4 plus 1 is 5. 5 comma 5. And then all you got to do is connect the dots. All right. Do you get that was probably faster than trying to graph all the parent points on a parabola and then move them all and then move them all again? I just have the points directly. If I just graph these 4 points, I'll only have to graph them once and connect the dots. Now, what if I do that and I end up with a parabola and I'm like, man, that's weird. Should I just blindly trust that that's right? No, I should think it through. Shouldn't my parabola have started here, then moved over here, and then moved up here? Do you see what I'm saying? If your answer doesn't make sense based on where it should have moved, then double check. Something went wrong. Okay? So here's how today is like that. Today we have a parent parabola, except it's not a parabola. It's that, which is what a log graph looks like. It's got an asymptote right here, and I'd like you to see it on Desmos. So grab your Desmos app and try to figure out how to type in y equals log. Let's do log base 2. Okay, I'm going to pause for a second. We'll pull that. Okay, to be honest, I'm not sure if this is going to show up on my video or not, but I have just graphed your basic log, and it looked like what I put up there, but it's a little bit more classy. All right, so let's compare log base 2 to log base 3. I'm just going to go back and put in another one, because that way I think it'll be able to show you the best example of, I'm going to add one. Comparing log base 2 to log base 3. Did you get that the green one took a sharper turn? All right. And one more I'd like to graph at the same time. And again, I'm going to go graph these real quick after I pull the app back down again, because if this isn't showing up on the video, I want people to see it. Make your third function, or if you already did a log base 4, that's fine. We're going to try an exponential. Okay, so that looks like, let's see if it's under. to the power of x is what I want to do. Maybe I should just try it that way. So 2 to the power of, like the caret, where's the caret? You guys know where the power of is?
You got the ABAD and then the uppercase, and the A to the power of B.
Oh my gosh. Wow, that took a while. Where? Oh, there it is. Okay, thank you. There's 2 to the x. Okay, now, do you get that those are kind of like a reflection of each other? Let me show you what they're a reflection over. I'm going to add one more graph. The line y equals x. Do you see how they're a perfect reflection across that line? All right, now that's what they officially look like. But just in case my my computer isn't able to record all that, I'm going to just do them on the smartboard real quick. That green one is what generally a log looks like. This is generally what an exponential looks like. And they are a reflection of each other across the line y equals x, which generally runs through there. That makes them inverses. This is your first example of an inverse. Certainly not your last. We do a lot of stuff with inverses. Inverse functions. All right. So some key elements. They both go through the point 1, but one of them has an x-intercept of 1 and the other one has a y-intercept of 1. I want you to think this through for a second. So let's say we have this one, which was log base 2 or whatever base, doesn't really matter. If I make its x-intercept, which is where y equals 0, what would this number have to be because the answer is 0? Do you remember that deal where you won the argument? Does that ever ring a bell? If I put a 1 right there, log base 2 of 1, log base anything of 1 is 0. If you don't believe me, you can type it in the calculator. Log base 17 of 1 is 0. As long as this is a 1, you have got a 1 in the argument, and you get nothing. I like to say if you won the argument, you got nothing. All right, so the point is, you're going to always have a dot there, unless I take this whole graph and go like plus 4. Then do you get that that point will move up 4 spots? It has to, because the whole graph moves up 4 spots. You know what I mean? All right, and this black graph, it's going to have this red dot right here. It has to. Why? Because it's like 2 to the x, and that's the y-intercept, which is where x equals 0. If the y-intercept is where x equals 0, then that's a 0, and anything to the 0 power has to be 1. That's why this always goes through 1 right here. Unless I go like this, plus 5, then the whole thing, including that spot, has to move up 5. All right, so I need to teach you a couple more things before you're ready for the whole, like, graphing a complicated log. I know I could now say y equals log base 3 of x, and you'd kind of go, okay, I think I remember that exponentials looked like this, and logs looked like that, and it's kind of like that. And if I needed exact points, I would make an XY chart. But what numbers would you pick? Can you pick anything you want? Can I put in -1 there? No, you can't have negatives there. That's why it never crosses this line, because you can't have negative numbers in the base. Okay, what would be a nice number to put in? 2? Do you think log base 3 of 2 is easy? No, it's not nice. But what would have been nice? 3 would have been nice. So I'm going to stick in 3. And then what would I get? When these two are the same, this is where those properties come in really handy. Instead of having to type in log base 3 of 3, I know it's 1. So over 3 and up 1 has to be on my graph. What's another one? 1. If you put a 1 in here, you've won the argument. And you get nothing. 0. And then one more thing. 9. Very good. Because if I put a 9 there, that's the same as putting a 3 squared there. Do you get if it was log base 3 of 3 squared, then it would equal what? 2. So there we go. I put in a 3 and I got a 2. And those are my 3 dots. Are they on my line? Yep. What do you think you need besides 3 dots? Asymptote. Now let me tell you how to find the asymptote. I know it's at 0. But how do you tell what it will be on a more complicated graph? It's whatever makes the argument part equal 0. So let's say it was like that. What would make the argument part, the red part, be 0? If you stuck in x equals 4, then you'd be able to find the argument. Sorry, not the argument. If you stuck a 4 into the argument part, and if it equals 0, if there's a 0 in the argument, then you're on the asymptote. Make up something funny about how if you have no argument, then you're on the asymptote. Okay, anyway. So, how about this? Log base 5 of x. Would you please, we don't want too complicated ones quite yet, other than just one little thing. Would you tell me 3 points and the asymptote for this function? Don't just pick random things like 9. 9 does not work nice. 4 does not work nice. 2 works pretty nice. Let's keep playing with the numbers until you find ones that work nice. And also, don't forget to find 3 points and the asymptote. Pause for a second. Let you try that one. Okay, Dice of Destiny. If I call on you, I want you to give me a point. Row 1, person 4. That's you, sir. I put in 1. And what do you think I get when I put in 1? If I put in a 1, I have just got a 0, and it's a good thing you found, but it's not 1, 1. When I put in a 1, you found the asymptote. Because this part right here became a 0. And if the argument becomes 0, you're on the asymptote. Okay. Give me another number. Random person, row 2, person 4. That's you. 6, I agree. If I put in a 6 right here, what do you get for the argument part?
5.
And then it's log base 5 of 5. And what's that?
1.
Raise your hand if you had 6 comma 1. A lot of people did. Next one, row 3, person 1. It's you, sir. You put in a 2. That didn't show up real well. I'm going to try again. 2. 2 minus 1 is 1. Ooh, you won the argument when you put in a 2. And when you won the argument, you get 0. There's 2 spots and an asymptote. Good enough? Nope. You have to have 3 spots and an asymptote. All right? Now, sometimes this last one's the hardest one to find. I know some of you are thinking, let's make it 25 here. But that's going to go off the graph. Yes. All right. So, if I could make this be log base 5 of 1/5, I would agree that would work really nice. Because that would be the same as log base 5 of 5 to the negative 1, and that means the answer will be negative 1. But how can I get this stuff? It's really messy. I'm going to clean it up here. This x minus 1 there. How can I get that x minus 1 to equal 1/5? 1 and 1/5. Very nice. I think a lot of people couldn't have done that yet. If I make this 1 and 1/5, then when I subtract 1, it'll be 1/5. See? And once it's 1/5, then it can be written as 5 to the negative 1, and then the answer is negative 1. So then you said 1 and 1/5 gives you negative 1. Now I have 3 points and the asymptote. I'm going to just sketch this thing, and then I'm going to look up kind of and figure out, does it make sense? That was the asymptote. Here's 2, 0. And here's 1 1/5, comma, -1. I'd be like there. Hey, I think it's working. It's curving like this. That's it. Very nice. What if I want to be sure? Then I go back up and look at the original, and I say, okay, it's a parent log that's been shifted 1 to the right. And then I look down and say, okay, it looks like it's been shifted 1 to the right, and it generally looks like a log. All right. These two graphs look very similar, and one's a log and one's an exponent. I like to think of this as, you know what a log is? It used to be a tree, didn't it? So a log is like a tree blown over in the wind. And then it becomes just a log. All right, so that's how I remember that. That's how what log graphs look like, is a tree blown over, because that's what a log is. As opposed to this other thing, which is an exponential, and most of you guys know what exponential growth is. It like grows faster and faster, and that kind of looks like exponential to me, exponential growth. All right, so the green one's exponential, the blue one's log, and they are inverses of each other. All right, you've pretty much learned everything that you needed to know. So they're just going to be more complicated. You know, like that might have two things happening. Log base 3 of x minus 1, or x minus 4 plus 1. What if I had to graph that? Well, XY chart, best friend in graphing. Stick in strategically. So like, who's got a good number right away? 4. 4 is awesome. Because it made this 0, and don't try to like do any more. You just go, ooh, that can't be 0 unless it was at the asymptote. So 4 is the asymptote. Next. I mean, why can't I keep going? Because you can't have a 0 argument. That part can't be 0, and this can't be 0 or negatives. The argument part has to be positive. It can't be 0 or negatives. So if you make it exactly 0 in here, you're finding the asymptote. Okay, another number, hint 5. How many of you used 5? Awesome. And you used it probably because it made the 1 in the argument thing. The danger is people just go, oh, there's a 1 in the argument, the answer is 0. Well, not the whole answer. This whole thing is 0, but then you got to add 1. So how many of you knew enough to put 5 comma 1? Okay, good. Get what I'm saying? The whole thing isn't 0, but this part is 0 when you put a 1 in the argument. Okay, the next thing is I'm going to put in a 6 and just try it in my head, and that's log base 3 of 2. Ew, don't like it. 7. 7 goes in here. 7 minus 4 is 3. Log base 3 of 3. That's not that hard, because those are the same. If these are the same, the answer is the exponent, which is, what's the 1 up? Oh, it's a 1 right there. So it's a 1. 1 plus 1 is 2. 7 goes with 2. Very tempting at this point to just be done and say, okay, I got my asymptote and I got 3 things. You have to have 3 points in the asymptote. So we need 1 more point. Who's got an idea? Yes. Ooh, I like it. 4 1/3. Everybody try it if you haven't already. Put in 4 1/3 and see what you get. All right, hold on just a second. 4 1/3 minus a 4 makes 1/3. Log base 3 of 1/3 plus 1. That part, because this part is 3 to the negative 1, it's negative 1 plus 1 is 0. You said 4 1/3, comma, 0, and you were right. Good job. That's the hard one. The hard one is trying to make this part into 1/3, which is like 3 to the negative 1. It's a hard sometimes to figure out what number it is that'll make that work. Okay, so you got 3 points and the asymptote. Roughly speaking, just a real quick graph, 4 spots over 5 up 1, over 7 up 2, over 4 and 1/3, which is just past the asymptote. It was at 0. There's 3 dots. Let's use blue. There we go. I have 3 points in asymptote. I'm good. There's your lesson for today. This gives me time to grade a bunch more projects. So let's go look at your homework. I will cut the homework down dramatically today. I need you to keep doing it. Okay, so here's our worksheet. We are doing the odd problems, so you may skip the evens. We don't always do just half, but this time I think it's appropriate. There's a bunch of questions, and you don't necessarily need that much practice. I know good people can disagree about this, but I think, I've been doing this for years now, that you probably don't need quite as many practice problems in the evening. It's what's important is touching it once tonight. That's in the 24-hour window. Makes it stick so much better. So honestly, I actually feel a little bit bad for the kids who get their assignment completely done in class, because then 24 hours from then is this critical moment where they might start forgetting that stuff. So do a little bit at home, just a little bit. It really helps it stick to long-term memory. I'm putting in a 0. Why? That seems dumb. Can't have a 0, but it makes the what? If the argument is 0, you've got the asymptote. Okay, and then if I put in a 1, I won the argument. 0. What if I put in a 2? That's just dumb. What's next? 3. If I put in a 3, log base 3 of 3 is 1. And then I just need one more thing. I would probably go with 9, just because it's easier than that whole fraction thing. You could have gone with 1/3. It would have been okay. But I'm going to use 9. Because log base 3 of 9 is really log base 3 of 3 squared, and that means 2 is the answer. Now if I graph these points, 0 is the asymptote. Over 1 up 0. Oops, I missed. It's down there. Over 3 up 1. Over 9 up 2. There we go. Graph my log. Remember, we're doing the odd ones. And that's all I have for the video for today.